also seen your ideas criticized as ignoring exaptation. I think that term started in the early 80s with Stephen Jay Gould and Elizabeth Barba. For example, they say that dinosaurs would have feathers, which at the time would allow them to stay warm, and then later allowed them to fly. Could you explain what exaptation is and how that applies to what you're talking about?
Yeah, exaptation in general means that you have something doing something else, and then you can you have a different need, and maybe you can take that from what it was doing and use it for something else. Maybe it's not great, but you know, you can improve it later. And I think Stephen Jay Gould or somebody wrote once about tires, about old tires that United States, you know, throws away its used tires, but folks over in Ethiopia, I think, get used tires and they cut out rubber pieces and they use them as sandals, so that they are taking something that was used for something else, a different purpose, and repurposing it. And so the idea in biology is that, well, you can repurpose a biological system. And that sounds attractive at first glance, but it falls down quickly when you give it the least critical critical examination. Again, let's look back at the mousetrap. You know, what is going to be exacted to give you a mousetrap? You know, you need a platform, you need the spring, you need the hammer, you need all these things. Not only you need pieces, you need them to be in the right shapes and to be placed in the right position, and so on. In my first book, Darwin's Black Box, I said, well, suppose you wanted to make a mousetrap from pieces that were laying around the garage. And so you had a wooden plank that you might use as the base. And you had a spring from a grandfather clock, and you thought you'd use the spring in your mousetrap. And you've got a crowbar that maybe you could use as the hammer. Well, of course, the point is you can't use those to make a mousetrap unless you substantially modify them first and attach them in the right way to each other. So all of that is intelligent activity. So you're still left with the problem of irreducible complexity, even if you fancy that there is some part lying around. Another point to keep in mind is that Darwin's theory should say that in principle, the thing that's lying around would not have been in the right shape, or certainly would never have been thought to be made for a new purpose. If it was made for a new purpose, that's intelligent design. So you would not expect any spring to be the right spring for a mousetrap, or any protein to be pre-adjusted to be the motor of a flagellum, or the propeller of a flagellum, or any such thing. And again, though that objection that you just talked about was done at least 10 years ago. And in that decade, and in the 25 years since these ideas first came out, no scientist has said, well, let me show exactly how exaptation would work for the blood clotting cascade or intracellular transport or anything real. These are just fancy stories that have some superficial plausibility, but nobody follows them up because their time is too valuable to go chasing after ghosts.
So it sounds like you're saying is those are all important and fine ideas. They just have nothing to do with what you've been talking about.
That's right. There might be something like exaptation. That's fine, but it's not going to explain the examples that I've talked about.
So whales losing legs and gaining fins doesn't, from land mammals to sea creatures, doesn't have anything to do with
No.
bacterial flagella. All right. Yeah, I think I can understand that one. How did Darwin devolve?
Okay, ever since Darwin first proposed his theory, he said, well, maybe a random change comes along and natural selection can kick in. And if it helps, then that lucky mutant and its progeny will increase as a percentage of the population and then eventually take over the population. But Darwin, as I've said, didn't know about what was in the cell. He didn't know about molecules. He didn't know about DNA. So he worked in utter ignorance of the molecular basis of life. But now science has elucidated the molecular basis of life in great detail. What's more, in the past 10, 20 years, science has developed new techniques to be able to very efficiently and quickly determine the sequence of genes or the sequence of a whole complement of the DNA of a species. And that's important because mutations are changes in DNA. And so in order to understand how Darwin's mechanism might work, you have to identify the mutations. And that was impossible before just 10 to 20 years ago. But now we can zero in and identify what exactly is the mutations that are providing these beneficial effects that are being selected by natural selection in various species. And the long and the short of it, as I discuss in my new book, Darwin Devolves, is that the great majority of the beneficial mutations, the changes in genes that are selected because they help a species survive, turn out to be ones that break or degrade genes that were already there. So in that sense, they are devolving. The organism is losing genetic information. It has less genetic information than it had before. And that turns out it can help it specialize in different niches of the environment, but it's not building any machinery or it's not adding to any genetic information. I begin the book with an example of the polar bear, which is supposed to have evolved from the brown bear, the grizzly bear, a couple 100,000 years ago. And it's just been in the past 5-6 years that scientists have sequenced the entire genome of the grizzly bear and the polar bear. And they were anxious to see what were the mutations that gave rise to the polar bear, starting with the grizzly bear. And of the top 19 genes, 2/3 of them, or 2/3 to 3/4, depending on how you count, were mutations that broke or damaged genes. One in particular you'd understand is a gene that provided or helped provide pigmentation for the fur of a grizzly bear was broken. And the polar bear doesn't have brown pigmentation and its fur is white now. That's helpful, it's real helpful in surviving in the Arctic, but it's due to breaking a gene, not making anything. And polar bears eat a lot of fat from seals, blubber of seals and so on, whereas grizzly bears eat berries and bunny rabbits and things like that. And it turns out that there's a gene mutation that allows the grizzly or polar bear to metabolize high-fat diets much more efficiently. And it turns out to depend on breaking a particular gene involved in fat metabolism. So again, this helps the bear specialize in a particular environment, but it's not building anything new.
So if I ask you, can devolution be creative? I think you've already answered that.
Yeah, no, I haven't seen it yet.
I read a review at the American Association for the Advancement of Science. And of course, if you disagree with them, then you're against advancements in science. And they reviewed your book, Darwin Devolves, and they said, Behe is skeptical that gene duplication followed by random mutation and selection can contribute to evolutionary innovation. Yet there is overwhelming evidence that this underlies trichromatic vision in primates. My question is there overwhelming evidence that gene duplication followed by random mutation led to blue, green, red vision in primates, including humans?
Well, the answer is maybe.
How can it be overwhelming if it's maybe?
Yeah. Well, this is an example of a review that, you know, dismisses things by waving their hand at a citation and saying this disproves things, and then everybody in the community says, "Oh, look, this book was shown to be wrong." But if you look up the citations and you think about it critically at all, it has pretty much nothing to do with the book. Yeah, in my book, Darwin Devolves, I devoted half of a chapter to showing why I no longer think that gene duplication can do the things that had once been attributed to it. And in my book, in Darwin's Black Box, I thought that one could start with a myoglobin-like gene, or a gene for a myoglobin-like protein, which again binds oxygen, as you mentioned earlier, and is thought to be the precursor of genes for hemoglobin, which is a more complex protein, has 4 copies of things that look like myoglobin. I thought maybe that could happen by random mutation and natural selection. Again, the point is, just because not everything can be explained by Darwin's theory doesn't mean that nothing can be explained by it, and maybe that could. And in my new book, I went on to explain why I no longer think that that could happen, that in fact, you can only get the most simple gene duplications and little changes. Turns out that the genes for vision receptors, vision proteins, are simple changes from each other. So there's no reason, or at least you can wonder about it, but those were explicitly not the kinds of gene duplications I was talking about. What's more, here's another problem you run into when you're a guy like me and publishing books like this, is that people see, even smart scientists, they say, look, in life, we see that there is this system. So evolution made it. So you said evolution can't make it, but look, it's right there.
Sure.
And this paper—
We call that circular reasoning and logic.
Yeah.
Logic.
Yeah, that's correct. And scientists are smart, but they have not been trained in logic and such.
But I'm sorry, go ahead, please.
Yeah, I was going to say the paper that these folks referred to, if you go back and read it, they just say, look, humans have 3 similar genes that underlie their trichromatic vision. And look, other species have 2 or 1 or 4 or something like that. But none of them have shown that these changes could have arisen by duplication and subsequent mutation, by just random processes and natural selection, that they couldn't be folded into the biology of the organism. Because if you think about it, any organism born with a duplicated receptor that was different from the first, that would be a birth defect. They wouldn't be able to recognize many of the things that other organisms could. And it's interesting to say to the listeners that this incident was in a review of my new book, Darwin Devolves. It was a review that appeared in a journal called Science, which is one of the top 2 journals in the world. And the 3 scientists who were the reviewers, first of all, there were 3 people assigned to review the book, and that's not normal. One of the reviewers was a guy named Richard Lenski, who's a member of the National Academy of Sciences and whose work was a major focus of the book. And the review is filled with these weak arguments about little changes in particular genes. So the point is that these guys would have been in ideal position to show that my arguments were wrong if they could, and instead they spent essentially all of their review discussing other things.
So in your books, you use various terms for genes. So just for the sake of my class in scientific apologetics coming up, how do you define a degraded gene?
Okay. A degraded gene, a gene is a sequence of DNA that usually does something. It makes or it has the instructions for a protein or RNA or something. A degraded gene is one that has a change in the DNA sequence of the gene, and that change means it no longer can perform the function that it had in other organisms in the species.
Okay, and you also use the term mutated gene, and that's what?
That's a gene that has a change in the DNA sequence of it compared to the genes of other members of the same species.
So that's how humans get superpowers.
Exactly. Or sickle cell disease.
Oh, well, I tell you what, I'll stick with normal genes if that's my, if the chance could go either way there. Okay, broken gene. What's a broken gene?
Broken gene is a little bit stronger term than degraded genes. It contains a mutation, a change in its DNA sequence that precludes it from making the protein that it used to make. For example, humans have genes for, say, hemoglobin. We have a couple genes for hemoglobin. Sometimes people are born with a change in one of them that no longer can make a hemoglobin molecule using that information. Fortunately, there are a couple of other copies of it, and they can go on to survive. But it's like taking a piece out of the mousetrap or something. Whereas a degraded gene, a broken gene is that, it can't make it. A degraded gene might make a similar protein that works less well, less efficiently, clunkier than the unmutated gene.
Okay. There's also, obviously, there's constantly ongoing research in biology, genetics, etc. For more than 30 years, you just mentioned, biochemist Richard Lenski of Michigan State did an experiment on E. coli, watching them grow more than 30 years. What did we learn from his efforts for the last 30 years?
Yeah, you think you had a dull life. He spent 30 years watching bacteria grow in a flask.
I've had a pretty exciting life, but I'll just leave that alone.
Yeah, so back in the day, back in the early 90s, Richard Lenski from Michigan State decided he would grow E. coli in a flask. And actually, he had 12 different flasks for replicability's sake. And he said, I'm just going to let these grow. And he would let them grow for a day. And then the next morning, he or his students would come in, take a little bit from each of the flasks and put it in a fresh flask, so that the bacteria would then grow for another day in the fresh flask. And then they'd come and transfer into a new fresh flask, and so on. And it turns out that bacteria, since they're so small, they undergo about 6 generations in one day under those circumstances.
Wow.
And in the past 30 years, his bacteria have undergone more than 50,000 generations. And there have been trillions of these little bugs in his experiment. And he did this just to see how they would change and evolve. And it turns out that the first, it was only months after he started this that he noticed that in one strain, a mutant bacteria was outgrowing the other ones. And this was great because here's exactly what you expect from Darwin's mechanism. There would be a mutation. If it helped, then they would outgrow and they would become the normal for the population. But back in the 1990s, the tools did not exist to let him determine what exactly was that mutation that allowed these bugs to grow faster. It wasn't until a decade later that these tools were invented for DNA sequencing. And it turns out that the bug that outgrew everything else had a gene region called the ribose operon. We don't have to worry about that. It had it utterly destroyed. It was deleted. It was thrown away. And by throwing away those genes, it grew 5% faster than ones that still had that. And going forward, he was able to track down other mutations, excuse me, which affected other genes and allowed the bug to grow faster and outcompete things. And only a couple years ago, he published a paper. He'd been publishing in the meantime, but a culmination of all his work showing that the top 40 genes that were selected that helped the bacterium the most, they all were either broken or degraded genes that were already in the starting bacterium. So I think Richard Lenski's work is just the greatest thing in the world, because this shows us in detail what Darwin's mechanism actually does. Mutations do arise, and sometimes they do help, but overwhelmingly what they do is help by throwing overboard genes that had been holding them back or which were not helpful in the new circumstances. It's kind of like having a ship that's sinking, and the best thing you can do is start to throw things overboard to help maybe let it reach a port. It doesn't matter if you throw overboard a car or a computer or other cargo that it's got. It's throwing those things out that helps. And so I spent a lot of time discussing his work in the new book, and this turns out to be a universal phenomenon, not just in bugs in a laboratory in Michigan. It holds for the polar bear, and it holds for dog breeds, and it holds for everything in between too.
Well, this is not on my list for you, but how does this reflect on the idea of junk DNA in our own genome?
Well, yeah, junk DNA was a concept that was, now you asked a little while back about an argument from ignorance.
Right.
This is a classic argument from ignorance, junk DNA. Back in
the atheism of the gaps.
Yeah, exactly. Back in the 70s, 80s, people discovered that there was a lot of DNA that did not code for proteins, and they didn't know what it did. And we've since discovered that there's a lot of control regions and a lot of programming that's held in that region. But back then they didn't know what it did. So they said, well, we don't know what it does, so probably it doesn't do anything. So a classic argument from ignorance. And so it was dubbed junk DNA because of that. But in recent years, decades, people have discovered lots of functions for that region of DNA that doesn't code for protein, but it does lots of other important things. And so even mutations in non-coding regions of DNA, in regions that don't code for proteins themselves, can be a loss of information because that region unlike what was thought, is rich with information that controls when genes are turned on and when they're turned off, and so on.
I remember the early days of Project Encode when they were looking for possible functions. There was some hand waving about that you only think it does these other things, but we can't show it does anything. So it's wasteful. But what you talk about, the E. coli, clearly shows that the life sheds inessential things, and it streamlines the process in order to maximize survival potential, in essence.
That's right. You wouldn't expect the genome to be carrying around a lot of stuff that didn't have a function.
Right. So we've talked about a lot of different subjects today, but if you could summarize your work in only a few words, and by a few words, talk as long as you want, what would they be?
Okay, well, 2 points, or well, 3 points maybe. The first is that Darwin and folks in his time did not know anything about the molecular foundation of life, but since the 1950s, discovery of DNA and so on, we've learned a lot, and we've discovered that the cell is run by machines, literal machines, just like a factory is. And these are sophisticated beyond our abilities to make. We humans cannot make these. They're extremely sophisticated and well regulated. Much of the machinery is so sophisticated that it cannot be made by a blind process such as Darwin's mechanism of random mutation and natural selection. And so we have to look for a different explanation. What's more, I should add, because it's a blind process, Darwin's mechanism actually does help things adapt to environments, but usually by throwing things away that it already had. And it essentially squanders genetic information for short-term gain. If it helps in the moment for a organism to get rid of a gene, for a species to get rid of a gene, yeah, it'll do so in a heartbeat, because it has no, Darwin's mechanism has no anticipation of the future. That requires a mind. And the last point is that whenever we see machinery, functional machinery, whenever we see computer codes and control systems and so on, we always realize that they are the product of intelligence, because it is only intelligence that can have purposes and that can order things in relationship to each other to achieve a goal that the intelligence has. We have discovered such things unexpectedly. Surprisingly, we've discovered them at the very foundation of life. And the more science delves into it, the more and more sophisticated we see it to be. So that is why I argue that life required purposeful, intelligent design.
And if somebody's watching this when it comes out, even on the Wikipedia, they have a whole page of molecular motors that describes the various machinery within a cell, and they list at least 15 different machines there. You can watch animations, you can click on the links to learn more about it there. So this isn't some kind of strange idea that you made up.
No, you can go into science repositories that have that hold scientific papers that have been published, and do a search on the term molecular machine, and you'll get tens of thousands of hits. This is not a concept that was made up by intelligent design proponents such as myself. This is just something that the data has required. These are machines.
Kinnison, little walking machines.
Yeah, they're so cute.
It is, yeah, it's unbelievable to think that there's not, of course, we don't believe in the idea that there's a force within us that provides life, in the sense of the old idea that of the spark of life type idea that would guide kind of a Aristotelian teleological urge within us. But it sure looks like it.
Yeah, absolutely. It's people. The big problem is that people in Darwin's day and still today used to think of cells and life as kind of squishy things. You know, they're kind of wet and gooey and so on. But it turns out when you look down through your microscope and get lower and lower, it's like having a telescope in space focusing down on a automobile factory or some such thing. You see machinery, you see purpose, you see order, all sorts of things like that.
Well, finally, when I look at our culture and how things have changed since I was a young man, the influence of now the postmodernism, those sorts of ideas, what I see is, what I've learned is that change comes when young people grow up with ideas that when they get into positions of influence, they can then begin to examine and speak for themselves. And in your case, it seems the forces of conventional evolutionary theory have pretty much stonewall any tabling of the insights of the ID movement.
Yeah.
You can use what I said or whatever you thought of, but where do we go from here?
Well, you're right. I think some famous physicist or other said that science advances one funeral at a time. So when the old guard, takes its leave of Earth, and younger people who first heard of new ideas and weren't yet invested in the old ideas, and they can fairly evaluate them and decide that, well, maybe we should give this other thing a try. So I think that will happen in biology too. How long exactly, I'm not sure, but one thing is for sure is that the data, the actual results of biology, are pointing more and more insistently away from chance and towards purposeful design.
Not surprising to me, but I'm sure hateful for certain people. But at the same time, truth and feelings don't have to match.
Mm-hmm.
Well, thank you so much for being on today. I really, really appreciate it. I'm sure the students from my class and the people watching this on YouTube are going to learn a lot from this, and hopefully they'll get their minds expanded and get their minds thinking in new directions that they haven't thought about before. Thank you very much.
That's great. It's been wonderful to be with you.
Take care. God bless. Bye-bye.
Bye-bye.